Hello all, myself Sweetie Rupani. I am coming up with a video series of subject data structure. Now when the term data structure comes into our mind, it's very simple that the word itself represents that it is a way of storing and organizing the data in a computer system so that it can be easily retrieved, updated and used. This subject is one of the core subjects in computer science and is very important and is widely used in artificial intelligence, operating systems, graphics, etc. While designing any application, an appropriate selection of data structure can improve the performance of that particular application. Let's begin with a video outline. Here I am going to cover introduction, abstract data type, classification, and operations on data structure. Now let's begin with introduction. So formally, data structure is a representation of a logical relationship between data elements. We mean to say they are logically related to each other. Physically, that is in a hard drive or in a memory, those elements are stored in the same way as the other data is stored. They may or may not get continuous memory allocation. They may be scattered on different locations depending upon the available resources. Data structure is a way of organizing all data items that considers not only the elements stored but also the relationship to each other. This is not just organizing, but also all the data is related with each other. Just consider an example of a pile of books kept on the table. Although those title of books are not related, but if we want to take book number 5, say, from that pile, so what we have to do is we have to pick all the books that are kept over the book number 5, and then we can pick our desired book. So who is below 5 and who is above book number 5 is known and is also related. Data structure selected for application affect the design of both structural and functional aspects of the program. As already discussed, the selection of data structure has a large impact on performance of an application. Now let's have a look at a need of data structures. Data structure is a different way of storing and organizing data that can be used efficiently. When we say it's storing and organizing the data, storing would again be a logical relationship. Physically, they may or may not be on the continuous memory allocation if we talk of a linear data structure. It is widely used in AI systems, we already discussed. This subject helps to understand relationship of one data element with other. It helps to store a data in a logical order. Physically, they may be located at the different memory allocations. It stores the data that may grow and shrink dynamically over the time and allow an efficient access. That is what is needed for almost all the applications. Let's have a look at an abstract data type. This is a very important concept if we look at the large applications. So ADT are important for a large scale programming. They package the data structure and its operation on them while hiding the implementation details. It just gives an overview that what all data items would be there for a particular structure or what all data type it can accept, which type of data it can accept, and what all operations that can be performed over there. So you can say that it is just a mathematical model which specifies logical properties and operations. Rather than going for how that operation is done, it just focuses on what is required to be done. So it would be made of primitive data types and operation details would be hidden. Now just take an example of a banking application. say if I am designing a banking application, I'll say that I'll make an entity for say transaction, which is one of the operation. So I'll just provide the name, that transaction, and I'll provide of course a specification for that, and that a transaction function will have the functionalities like withdrawal, deposit, balance inquiry, and if any charges are applied on account, those all things would be provided in a transaction. Now, how it is implemented, in which programming language it is implemented, is totally upon a developer. We are, when while designing an abstract data type, we are not focusing on which programming language would be used. We'll just build a basic building structure. How it will be implemented will be decided by a developer. Let's have a look at need of ADT, need of an abstract data type. It gives an overview of data structure and clear idea of how a model will be used and how it's going to function. It is language independent structure. So once you design a structure, you can build it using any programming language. It has flexibility, so that is flexibility with a developer. In a large-scale development project, ADT always helps in reusability across various modules. If the same functionality is implemented in a multiple modules, you can keep a uniformity and reusability of a code if both the modules are designed using the same functionality. Let us have a look at primitive and non-primitive data types. While studying the programming language, we all are aware with primitive data types. So primitive data types are those that are provided by a programming languages, whereas non-primitive data types are those that are derived from the primitive one. Say consider a programming language C. In C, we have integer, float, char, those all are primitive data types. Whereas if I say I am building a structure student, then that would be a non-primitive data type because it will have a collection of a primitive one. So these data types are used to store the group of values, non-primitive data types. Now let us have a look at classification of data structure. Data structure is broadly classified into a linear and a non-linear data structure. Now, when we say that a particular data structure is a linear or a non-linear, this classification is on the basis of how the data is accessed rather than how the data is stored. This is very important. People make mistakes. Linear data structure, when I say that stack is a linear data structure, in that case, the way the values are accessed from the stack is in a linear fashion. That's why we say that stack is a linear data structure. Similarly, when I say that a tree is a non-linear data structure, so the way that it is accessed, the way the values are accessed from the tree, decide its type. We'll have a look at a stack, queue, linked list, tree. Then let us look at them one by one. So beginning with the stack, stack is a linear data structure with the last in, first out. That means it's a box. You can consider stack as a box closed on one end and open on the other end. The end which is open, you can have insertion and removal from a single end. So the element that is kept in at the last would come out first. So when element is inserted and removed from the stack, the base, that is the values that were inserted below that particular element, would remain same. And top is a variable that keeps track of where the last value is and who is on the top of the stack. There are two main operations on stack, push and pop. Push is nothing but inserting a value, and pop means deletion of element from a stack or a removal of an element from the stack. These are two main operations. We have three different auxiliary operation or a supportive operation. When I say it's a supportive operation, it means it is going to help main operation in that task. So we have three such operations: isEmpty, isFull, and peek. IsEmpty function would check for if a stack is empty or not. IsFull will check for stack to be full, and peek is going to check for who is on the top of the stack. Stack can be implemented in two ways. One is a static implementation, which would be by making use of an array. The other one would be a dynamic implementation, which would be by making use of a pointer. Let us have a look at a queue, which is also a linear data structure. We all are aware with this particular data structure in our day-to-day life. If you go to buy a ticket or if you go to a shopping market, everywhere you will get to see a queue. This is the same thing. The one who goes in first in a, of course, in a billing counter, consider in that case the one who is first standing in a queue for a billing would be responded first. So there are two open ends. From one end, the removal takes place. From other end, insertion takes place. So new elements are added from a rear end, whereas the elements are removed from the front end. Those operations, we refer it as an enqueue operation and dequeue operation respectively. Again, queue can be implemented by making use of array or by making use of pointer. Depending upon the application, depending upon how much flexible you are with the size of a queue, you can decide one of these implementation. If you already know the size of your input, you can go for an array implementation. If you are not aware with the number of elements in your queue, then you can go for a dynamic implementation. There are various types of queue: simple queue, circular queue, priority queue, double-ended queue. All of them has its own advantages and disadvantages. We'll go into detail when we go for a particular unit queue. Let's have a look at one more linear data structure, which is linked list. This has totally dynamic memory allocation. So you can see over here, there is a head which keeps track of who is at the beginning of the list. And here you can see two values. One of this is data, actual data, and this is an address of a next node. So the one who is here in the front needs to keep address of its next node. Similarly, this node will keep an address of its next node. When there is no one after that particular node, will store it as a null. So address part of that particular node would be null. You can consider this as a line, people in a line waiting for some ticket. In that case, there is one person who is keeping track of who is after whom. So he'll just keep track of who is at the beginning of the node. That person in a queue would be told who is next, and they need to keep track of who is next to them. So we need to store an address just because these memory allocations are not continuous. As and when needed, we allocate a memory, so we'll not get a continuous memory allocation. There are various operations on the linked list: insertion, deletion, traversal. There are different ways in insertion and deletion as well. We'll look into its detail when we go for a unit linked list. Again, there are varieties in a linked list. can have a single linked list, doubly linked list, or a circular list. Depending upon your application, you can select the desired linked list. Now let's have a look at non-linear data structure. The first data structure we are considering in a non-linear category is a tree. So when this term comes into our mind, tree, we think of some root, branches, and the leaf. So those all terminologies are related over here as well. But when we assume a tree in our normal life, we just think that a root would be in the ground and a tree would be growing in an upward direction. But over here in a data structure, we'll have to just assume the tree in an opposite direction, inverted. So we say that tree represents hierarchical relationship. Over here also tree will have a root, but instead of root in a downward direction, we'll have root in an at the top. And as and when tree grows, it will grow towards the downward direction. So tree always grows in a length towards bottom. Of course, we will have a leaf node which cannot be further expanded. We will have a branches which we refer it as an edges. So this is a tree of a data structure wherein you can see root at the top. Here are edges which is very similar to a branch. There are two branches. If a tree has the two branches, those branches would be referred as seedling. This is a subtree. With this particular parent, you can assume a tree structure as your family tree, wherein grandparent is on the top, followed by parent, followed by child, and grandchildren. So as and when tree grows, it grows in a downward direction. A tree can be used for building a family tree as well. These are the leaf nodes which are not further expanded. Let us have a look at one more nonlinear data structure, which is graph. So a graph has a set of vertices, as you can see over here, and a set of edges which are connected in some random manner. There are two ways in which you can represent this graph: by making use of an array and by making use of a linked list. Depending upon how big your graph is, how much data it has, you can decide as which implementation you would go for. These are two examples of a graph. When we assign a weight to an edge, we refer it as a weighted graph. And here you can see a direction as well, that we can go from V1 to V3 with a unit 15. So that is showing me the direction, and a weight is also given. So that is a directed and a weighted graph. While over here in this graph, directions are not given, so you can go from V1 to V2, V2 to V1. Again, the edge weight is not mentioned, so you can consider this as a one unit. We'll go for this in detail while going for the unit graph. Graph would be widely used for, we can consider it is used for a routing networks in order to build a routing network for, say, mobile company. So in that case, how many towers it has in a particular area, they can make use of this graph in order to represent that. Again, it can be widely used in, we can consider a Facebook, wherein it is showing you a friend suggestions. How it is showing? It is making use of graph. Friend can also be your friend. So that is the suggestion, which is an outcome after processing this particular graph data structure. Your whole network is stored. Your friends and their friends are stored as a graph. If you are directly connected to a particular person, they are directly having edge with you. But a friend's friend you may not be knowing, so there won't be any direct connection between you and your friend's friend. There are different types of graph. Depending upon the application, you can select one. It can be a directed one, undirected one, simple graph, weighted graph, connected and a non-connected graph. We'll look at these details while going for a graph. Various operations that can be performed on the data structure, overall on all data structures, that is insertion, deletion, traversal, merging, sorting, searching, those all things can be performed on the data structure. Thank you everyone. If you like my video, you can subscribe to my channel in order to learn data structures, analysis of algorithm and Python programming. Thank you.